to the cloud. All right, so let's put up our first problem. All right, like I said, I'll keep an eye on the clock. I'll give you about a minute head start if you want to see if you can factor this. All these problems today we're going to factor. So go whatever method that you like. I'll probably stick to the AC method because that's what most of you are going to like. And like I said, I will start writing here in a second. And if you have questions, please just chime in. All right, so remember, we always have to look for the greatest common factor. So in this case, the greatest common factor is 2x. So I pulled a 2x out of each term, which then leaves me the 2x on the outside and the trinomial inside of 2x to the fourth power plus 7x squared minus 4. And then if we go look at our little table, this is got 3 terms. So therefore, the only way to solve this is by factoring. Like I said, I will go through and do the AC method. So AC method. Step 1, remember you multiply A times C, which is the 2 and the negative 4. So step 1, 2 times negative 4 equals negative 8. And then step 2, the factors of step 1. So my factors of negative 8 are just 1 and 8 and 2 and 4. And I don't put the negative sign in quite yet until I get to step 3. That's just what I do. So step 3, find factors that sum to B. So in my case here, my B is a positive 7. Right? So if I make this a negative 1 and a positive 8, negative 1 plus 8 gives me a positive 7, and negative 1 times 8 gives me my negative 8. So that is my good set. So I like to circle it. And then remember step 4, I run out of whiteboard here, rewrite. So I rewrite this now as, and don't forget your greatest common factor. So I want to bring him down in blue so I don't forget about him. And now I rewrite the middle one. So 2x to the 4th plus, let me fix that. minus, I'm going to put the 1 in there just to remind myself where it came from. And you got to remember to put the variable back in. So I get a minus x squared plus 8x squared minus 4. And I close up my brackets. And the only reason I'm using brackets is just I'm attempting to be neat. Now, the final step, which I wrote to write, step 5, is grouping. So now I group these things together. So I put parentheses around the first 2, parentheses around the last 2, and I do grouping. So don't want to forget about so here's step 5. I don't want to forget about my greatest common factor, so I'm going to bring him over here in a different color. I'm still going to leave my brackets to try to help me keep neat. So if I look at this first one, I can see what's in common is if I take out an x squared. So if I pull out an x squared, I am left with 2x squared minus 1. And I go to my second grouping, and if I take out a 4, a positive 4, I am left with 2x squared minus 1. And unfortunately, I ran out of room, so we're going to have to go to the next page. I'll put my bracket back in so I'm neat. So I'll give a second for anyone who's writing this down before I go over to the next page. Because all we have to do left to finish the problem now is put these two things together and rewrite one of the parentheses, and you have the final answer. So let's go over to the next page here for a minute. See if I can rewrite all this from memory. So I have 2x bracket 2x squared minus 1. I think I pulled out, see, I forgot already. I pulled out x squared out. Pulled out an x squared, then I pulled out a positive 4, 2x squared minus 1. Now remember, when we're doing grouping, these two things have to be the same, which they are. So now my final answer is 2x parentheses x squared plus 4, 2x squared minus 1. Now, if you have these in different order, like if you swap the x squared plus 4 and the 2x squared minus 1, that's fine. That's the commutative property. But if you have these 3 groupings as your final answer, and you were working ahead of me, then you have done it correctly. So remember, it's like playing Jeopardy. So we started with 4x to the 5th plus 14x cubed minus 8x, right? And then we had to factor this. And when we did, we got that as an answer. We started by looking for the greatest common factor, and then we did the AC method. Give everybody a chance to write that down if they want it. All right, how are we feeling? Any questions? Again, if you don't want to ask, you can just type in the chat as well. All right. I will come up with another problem then. Go to black. So, and again, please make sure that you're feeling good with this. If you have questions, please ask. Because when we get into fractions, our fractions aren't going to be like 2/3 plus 3/4. It's going to be a trinomial over a trinomial plus another trinomial over another trinomial. And the only way you're going to be able to combine those fractions is by factoring. So we have to make sure we know how to factor before we move on. That's why I'm taking today to make sure we're comfortable with factoring. Because the rules of fractions are just like the rules we already used, but if you can't factor, then you can't apply the rules. So what about this guy? 4x squared minus 64. Again, I'll give you a second to see if you have any questions. Check in chat. No questions in chat. And please, also, if you don't want to ask me in chat and you want to ask someone that you usually sit by in class that always like to work with, then you can easily click on that person's name and send them a private chat in the course as well, and talk that way if you like working with somebody. All right, so just like before, first thing we should look for is to see if it has a greatest common factor. And if you look, you can see that 4 is our greatest common factor. I think 4 goes into 64. Yes. So I pull out a 4, and I'm left with x squared minus 16. And then we have to look at our little table again. And we have 2 terms now. So 2 terms, we have 2 options. This could be a difference of squares or a difference of cubes. Well, because this is a square, then I'm pretty confident this is a difference of squares. So, like we did last class, the easiest way to do this, put a square root over the first term, put a square root over the second term. So again, don't forget your greatest common factor. He comes out. The square root of x squared is x. The square root of 16 is 4. We keep the sign, and then we rewrite it with a positive. And there is our answer, because this is a difference of squares. Questions? All right. Try another one then. So there is no greatest common factor in this one, because the only thing that goes in 9 is 9 and 3, and neither 9 or 3 go into 64, so therefore there is no greatest common factor. So the only thing we do is the AC method, right? However, if we kind of pay attention here, this is one of the special cases. If I just take the square root of this first term, and I take the square root of this last term, because they look like perfect squares to me, I get 9, the square root of 9y squared is 3y. The square root of 64 is 8. Right? And this has a plus sign, so therefore this is a plus. Now, what I have to check is this guy. I got to check to see if my middle term is okay. And how I check is I multiply the 3 times the 8, and then I also multiply it by a 2. Right? This is, you always multiply it by 2. So 3 times 8 is 24, and 24 times 2 is 48. And that is the same as that. So this thing is called a perfect square. And since it is a perfect square, my answer is 3y plus 8 squared, which equals 3y plus 8, 3y plus 8. And if you do the AC method, it will also work, all right? But there is that special case that we had on the table called a perfect square, right? And the formula for a perfect square, I'll come back to this in a sec just so you can see the formula, is a squared plus 2ab plus b squared equals a plus b squared. Or if I have a squared minus 2ab plus b squared equals a minus b squared. And notice in both of these is the number 2, and that's why we have to multiply the previous problem by 2 to get the middle term. So if I come back to here, then you can see where I get this 48 from. Now, the only time I ever attempt to check this is if the first term looks to be a perfect square and the last term looks to be a perfect square. Again, if you don't see this, the AC method will work. The problem with the AC method is step 1, you have to do 9 times 64. Now you get this huge number, and you have to find factors that add up to 48. So sometimes AC method, it can become a little overwhelming. So if you're looking at a problem like these are pretty big numbers, check. 2 things may have happened. 1, you forgot to take out the greatest common factor, or 2, it's one of the special cases, all right? So I just saw I had a question here on chat, so let me check that. Okay, I didn't get rid of the 48. What I had to do was check to see if this was a perfect square, to see if I come up with the 48. Remember, what you're trying to do here in these problems is, I didn't get rid of anything. If I FOIL this, I will get this. And remember, let's do that so you can kind of see, because I'll show why the 48 didn't go away. 3y plus 8 times 3y plus 8, right? So if I FOIL, multiply those 2, I get a 9y squared. First outer. Then I will multiply those 2, and I get a 24y. Then I multiply those 2, and I get a 24y. And then finally, I multiply my outers, and I get my 64. Notice, again, I have a 24y and a 24y. I have 2 of those. There's where the lovely 2 comes from again. But when I combine my 2 middle terms, I am back to where I started. That is the point of, not 16. Remember, the purpose of factoring is kind of like playing Jeopardy. You're asking yourself, what 2 things did I multiply by to get this? And the answer is, I multiplied those 2 things together to get this. It's kind of like working backwards. You already know the answer. You're asking yourself, how did I get there? And again, this doesn't make a ton of sense of why we would ever do this right now. But we got to get the methodology down before we kind of move on. And what you're going to see is when we get into fractions, this will help us out a lot. And then we get into chapter 7 of solving this. So in chapter 7, like I said, what we end up doing is saying, this equals 0, right? Well, to solve for y in the quadratic form is challenging. It is much easier to solve this, the top one, than it is the bottom one. So we will factor so that we can actually solve for y. And we will learn how to do this in chapter 7. Good questions. All right. Anyone need me to go back any screens because I went too fast showing the reason why here? Or do you want me to start another? Can I go on to another problem? I'll wait a minute to see if I get any questions. Again, I will upload this video. I'll call it Factoring Examples on the YouTube page. Then you can kind of go back and kind of see some of the processes we were doing. All right. So let's move on then. And again, first thing we always start for, greatest common factor. If we look at this, we can see that they're both even, so I know at least a 2 can come out. Is minus 125. And now I go to my table and I say, all right, 2 terms. This is either a difference of squares or a difference of cubes. Now, it's the only choices I have. So again, I start with easy thing to look at, my power, my exponent, and I see it's a 3, which leads me to think this is a cube problem. So then what I have to ask myself, right? So if I take the cube root of this, and I then also have to take the cube root of 125. Now, last class, I put up the common cubes to try to remember, or again, make sure you know how to put this into a calculator. But we got to verify that 125 is a perfect cube, and it is 5. So I bring down my greatest common factor. Sorry, take the cube root of x cubed, remember, and the little trick was, I take the number on the outside, put it underneath, and I can divide it. 3 divided by 3 is 1, so therefore this is just x. I bring my sign down, and then the cube root of 125 is 5. So there is my first part. Now, we have to go back to the formula, right? And I'll write the formula right below so we can kind of see it. Remember, a cube root was a cubed minus b cubed equals a minus b, right? We found that by taking the cube root, so we've done the first part already. And then the rest of the equation was I took my a and I squared it, so I get a squared. I go from a minus to a plus. I multiply the 2 things together, and then I square the last term. And there is the formula. So if I do that for the problem we're working on, I square the first term, I change the sign, I multiply the 2 things together, right? So it becomes a 5x, ignoring the sign, because you already took care of the sign thing. And then I square the last term. Well, 5 squared is 25. And there is my answer. So, like I was saying in our last class, the 2 terms can be the hardest because you either know how to break them down by the formula or you don't. There is no methodology per se, like the AC method that you can kind of walk yourself through. You got to look at things and say, is this a squares or a cubes problem? And if it is, kind of follow what the formula says. No, you don't need to FOIL the answer. You can if you want to check. So this is a nice way to see if you got the correct answer, because if you do FOIL it, you should get back to where you started, right? But no, I'm not going to make you FOIL. We did that back in chapter 1. So this one is just all working backwards. But it is a good way to check and make sure you have the right answer. And especially when it messes with this cube one, because it can get kind of crazy and ugly. It can work. You know, a lot of things will cancel out, obviously, because you go through this big term expression that's in the green box to your back to the beginning. But not required, but good way to check your answer. All right, how are we feeling? We want to do a challenging one? Nah, yeah, I got a yes. All right. Yes, that is an 81. I'll clean it up a little bit. All right, I'll give you a hint. I'm gonna let you guys work this for a second. I won't go going into it too fast. There is a GCF for this problem. All right, so if I start with the easy thing here. Notice there is a single y here and 7 y's here, so I can pull out at least a single y. And then I have 2 x's here, and I have 5 x's here, so I know I can pull out an x squared. The tricky part is what to do with these numbers. See, as we get into algebra, the letters become a little bit easier to know what to do with. It's the numbers that become a little tricky. All right, so remember the cool rule with 3s. If I add up the numbers and that number is divisible by 3, the whole thing is divisible by 3. So 1 plus 9 plus 2 is 12. 12 goes into, 3 goes into 12, so therefore 3 goes into 192. 8 plus 1 is 9. 3 can go into 9, therefore 3 can go into 81. So I know I can pull out a 3. And then when I pull out that 3, now I have to do out the divisions. So 192 divided by 3 is 64. I took out a y, so this becomes a y to the 6th. I took out 2 x's, and so remember when we take things out, we subtract. So 5 minus 2 is 3, so this becomes an x cubed. This is a plus. 81 divided by 3 is 27. I already took out the y, so he's gone. I took out the x's, therefore they're gone. And there we are after we take out the greatest common factor. So now we look at this and we see we have 2 terms. Quick hint here, this is a plus. We only have one problem under 2 terms that can do a plus, and that is the sum of cubes. And this power is divisible by 3, and this power is divisible by 3. So then all I have to ask myself, can I take the cube root of 64 And can I take the cube root of 27? So I'm going to let you work that for about a minute to see if you can apply the cube root formula on your own. And then I will start applying the cube root formula so you can kind of see how we go through this. Oh, that's how I would start. Bring down my greatest common factor, and then take the cube root of each term. And if I take the cube root of 64, I get 4. If I take the cube root of y to the 6, I get a y squared. If I take the cube root of x cubed, I get an x. I keep the sign. Cube root of 27 is 3. And there is my first grouping. So now what do? Now I go to the formula, and the formula said the first thing I do is I square the first term. So I am going to put a 4y squared in, I'll put this in this parenthesis so you can see the formula being applied. Oops, and don't forget your x, 4y squared x. I then change the sign. I multiply the things together. And then I square the last. That's what the formula tells me to do. Now I have to simplify this. So bring down my greatest common factor. Write my first grouping. And then simplify. So 4 squared is 16. Y squared is y to the 4th. X squared is just x squared. Negative 3 times 4 is a negative 12, y squared x. And then plus 3 squared is 9. And there is my final answer. Any questions?
Would Pearson mark it wrong if you did like 16y to the 4th x squared instead of like x squared y to the 4th? Like if you swapped them? Okay.
No, if you swap them, that is perfectly fine. No, it will not be an issue. And I think most of the Pearson homeworks are multiple choice too, so that helps because you can just click on the one. But if not, yes, the commutative property allows me to rearrange these things. It doesn't matter. And technically, you can rearrange things in the parentheses too, and it wouldn't be wrong. So, any other questions? I want to try to do one more AC method and then probably call it. We've done a lot of special cases, but we haven't done another AC method for a little while. All right, let's try this guy. This one's not too bad, so I'll give you a minute or so to see if you can walk through the whole process and factor this one out. And if anyone has any questions, please ask. Remember, step one, you multiply A times C, and in this case, there's no A number there, so if you want, put a 1 in just to remind yourself there's something there. So 1 times 15 is 15. And then we'll list our factors of 15. So 1 and 15, 3 and 5. All right, and then we need to get our middle term, which is a -8. So the only way I'm going to get this to be a negative, if I do a -3 and a -5 will equal a -8. And a -3 times a -5 gives me a +15. So it's okay to do this because it works. So now what I do is I rewrite my expression with my middle terms that my factors I found at work. So x squared minus 3xy minus 5xy. Oh, that's an ugly 5. All right, and don't forget to write your letters down. A lot of times people do the AC method, they just focus solely on the numbers and they forget they have to put back in their variables. So whatever variables are here, make sure you put them back in, because if you don't, then your grouping's not going to work. Plus the 15y squared, right? And now we go to grouping. So group the first two, group the last two. And because it has a minus, what I like to do is put the minus in the parentheses and then put a plus between them to remind myself I am not multiplying, I am adding these things. Then I look at my first grouping and it has an x in common. So I pull out an x and I'm left with an x minus 3y. And then the other one has a 5 in common, so I pull out a 5, which leaves me a -xy plus 3y, plus the y, thank you, which leaves me so the y comes out, thank you. This gives me a +3y. But notice, these two things are close, but are not exactly the same, right? So this is why I like to do the little blue plus I did, because I also need to take out this negative sign. So if I pull out the negative, he becomes a -5y, which now makes this guy a +x. But then since I took a negative out of the first term, I have to take a negative out of the second term, which makes him a -3y. Now my two things are the same. All right, so if you get close, but they're not quite the same, check to see if you change the sign on it, if that will help. And then because I ran out of room, draw a little arrow. Group my outer terms, so this becomes an x minus 5y, x minus 3y. I cannot write nice 5s, can I? And there is your answer. So this one, the numbers didn't get too big, but you had to be careful with the signs. We had to manipulate our signs here to be able to get to a -8. And then we had to manipulate our sign here to get our two groupings to be identical, right? So sometimes if you're close, but you're not quite getting there, check it, and it might be something as simple as you just got to kind of play around with the signs a little bit. And if you do that, it might just work out in your favor. All right, so we've been doing practice problems for about 45 minutes. We still have another 45 minutes if we want to keep doing practice problems. Or if anyone else has any questions, like I said, class goes faster on this because it's not so as many questions, and I'm not giving you as long to work on problems because I can't see what everybody's doing. So I don't really have anything else. I can give you more problems if anyone wants to stay and work. I can also answer any questions if you want. Make sure that you are comfortable with this. Start the homework, practice some of these, because next week when we get into fractions, right? So there's kind of a little pre-teach here just so you can kind of see my point. Right? We're going to spend like 10 seconds, maybe 2 minutes on how we do things like this, right? Just to remember the rules of fractions. And how do we do things like this? Just to remember the rules of fractions. But what we're going to end up getting ourselves involved in, oops, 3x squared, going too fast, 3x squared plus 4x minus 2 all over 6x squared minus 7x plus 8. That's what we're going to get into mostly, right? So we're going to refresh real quickly on Monday on the rules of fractions, but then we're going to jump right into this, right? And then how do I clean this thing up? Well, you clean this thing up by factoring. So we must make sure we are halfway decent with our factoring before we get into fractions, because the only way we can do this is by factoring. Because what you're not allowed to do, you're not allowed to say, oh, I can reduce -2 over 8. I can't break apart a polynomial. So I have to factor this to break it apart. So that is the key to fraction. That's why I wanted to spend today practicing factoring, because we're going to be doing fractions, and the only way to do fractions is by factoring. So if you want to stick around and want me to keep working or have questions, please stay. If no one sticks around, then I will just end the class. All right, but I don't mind keep giving practice problems, but I don't want you to feel that you have to continue to stay. But if you want to, I'm fine throwing practice problems up on the whiteboard.
I have a question from one of the homework problems on Pearson.
Okay.
It was like solve for the indicated variable, and I'm assuming that goes back to like the problem was 6a minus b equals ab plus 3.
6a minus b equals what?
ab plus 3.
AB plus 3. Okay.
AB, not 8. Sorry.
Oh, AB. Thank you. All right. I'm going to come back to this. Tim had a quick question about a previous. So, Tim, you asked me to go back to this guy. Is that what you wanted, Tim? Tim, you still here?
Yes, sorry.
Yeah. Is this the problem you were asking me about?
Yes.
Okay.
Now, how did you flop that last part?
Where the yellow circle is?
Yeah.
I basically divided everything by -1. Because if I took out a -1 is basically what I took out here. So,
Oh, I see now.
Yeah, so it went from a +5 up here to a -5 down here because I took out a -1 to change the signs in the parentheses so that the two polynomial groupings were the same. Because if I don't do that, they're close, but they're not exactly the same. They must be identical for the grouping to work.
Okay, thank you.
Yep. Now what did I do with yours? There we go. So, what was it asking you to solve for this, Selena?
Just A.
Okay, solve for A. Perfect.
It says like solve.
Yep.
Yeah, A.
So to get this thing to solve for A, I would do just like I did before. So basically, since all I care about is A, I'm going to treat B like it's a number, right? So if B was 7, I would add 7 to both sides, right? Well, just to make my life easier, I will to keep treating it like a b. So if it's a minus b, I just add a b to both sides. So then I get a 6a equals ab plus 3 plus b, right? And if that would have been a 7, I could have combined the 3 and the 7, but since it's a b, I can't do anything else.
Mm.
And now I need to get the a's on both sides, so I'm going to subtract an ab. So now I have 6a. Oh, should have done it a different color. 6a minus ab equals 3 plus b, right? Now, it's kind of like what we did today. If I put this in parentheses, I can pull the a out, right? Because it's common throughout.
Mm-hmm.
And I get a 6 minus b equals a 3 plus b. And now to get a by itself, I just divide this side by parentheses. That's supposed to be a 6. But, 6 minus b. I'm dividing. So then I divide this guy by parentheses 6 minus b, because I have to keep the things together. So therefore, a equals 3 plus b all over a 6 minus b.
Okay. That's a
And this kind of gets into what we're doing next time. This is a fraction. And even though these are both b's, I cannot cancel them. I cannot cancel parts of a polynomial. So this is why this is the final answer. I cannot cancel those things. As much as my brain wants me to, because there's so much in common, I'm not allowed to.
And in the beginning, so like, is the reason when you add the b over to the other side, you don't combine those b's together?
Correct.
Okay.
Because the other b has an a attached to it and the other one does not.
That's what I thought. Okay, just double checking.
Yep.
Thank you.
You're welcome. Any other questions or things you want me to go through? I don't know how many people we still have in the class. Let's see here, participants. No, we still got 10 of us in here. I said I can do more problems. I can do whatever you like, or we can call class early. That is 100% up to you.
I've got a question.
Yep.
On one of the problems you did earlier, the 9y squared plus 48y plus 64, which was,
Yeah.
You had
I
said
got
you could factor that out AC.
Yep.
And that's what I was trying to do because I didn't recognize that
Okay.
it was.
All right,
I
you want me to do the AC method?
Yeah, I couldn't do that. I couldn't make it
So
come
let
out
me-
because it's supposed to, the factors of 9 times 64 should add up to 48, right?
Yep.
Yeah,
So
well,
9y, it was 9y squared plus 48y plus 64, right?
yeah.
Okay. So the AC method says I multiply 9 times 64.
Which is
9 times.
576.
Okay. So that's 576. And then I'm going to cheat because I know 24 has to go into this somehow. Yep. So if one of the factors of 576 is 24 times 24. And then 24 plus 24 equals 48. This is the problem with the AC method. Sometimes the numbers get big really fast. So you'd have to keep listing factors, and it would have probably taken a bit to find out that 24 went into both. The only reason I knew it did because I knew the answer had a 24 in it.
Right.
But yeah, the 576 is a big number, and it has lots of factors. So you basically would have to, 5 plus 7 is 12 plus 6. 3 can go into it. 6 can go into it. I think 4 can go into it. 8 can go into it. You know, so it takes a minute to get all the way up to 24 because 576 has a lot of factors. Typically on the test, I'll make sure I don't pick problems that, just in case people do the AC method, don't climb that fast. But that's why I wanted to do one of them where it did, so you can kind of see if I got numbers that are really huge, I would hopefully remind myself that maybe it's one of the special cases to check. It may not be. It might be one that just doesn't work. But come test time, the test will not be so crazy. That's why I try to do tougher problems in class.
All right. Thanks.
Yep. Any other questions? All right, I think today was hopefully beneficial for you all, that you at least got some of the practice of the, got to see how to do some of the lessons from last class. I will definitely upload this video today so you can review us going through some of the calculations of 6.1 through 6.3. And then on Monday, we will start on the fraction part of the chapter, which would be 6.4 through 6.7. Probably cover like 6.4, 6.5, maybe a little bit of 6.6 on Monday. 6.7 is kind of a tough one, so I'd like to do that one by itself. And then that'll give us time on Wednesday to do 6.7 plus practice and problems again, like we kind of did today. So if no one else has any questions, have a wonderful weekend. Again, you can always send me emails as well as you work through the homework if you get stuck. And if we need to, we can always set up some private Zooms. Typically, our class, I have nothing before our class, so I'll try to log in early. So if you do have questions, just log in early and I'll be here and you can kind of ask. Remember to set up your Pearson accounts, and I will see everyone on Monday.